Hello, and welcome to another exciting episode of Cooking with Unity. I'm your host, Max Moreau, and with me is my co-host, Philip Wilson.
Hey, how you doing?
So, sorry we missed you on Thursday, and we're complete no-shows. We were both tired, and we can work through our busy schedules usually pretty well, but both of us being tired on an episode does not pan out well. So, trust me, you would rather us not have done that episode. So,
Yeah.
So let's get to the screen. So on our last episode of Dragon Ball Z,
What did they do? Did they go, "Ah!"
probably. That's a lot of fun, actually. You were holding back.
I was.
You
I could have gone much louder.
Yeah.
Did they say Kamehameha?
Yeah, maybe.
Was there
They might have.
actually a spirit bomb?
No,
Or did
no.
they just charge
He
it
just
for the whole
charged it for
episode?
like the whole episode. So, we're on the hype map generator. So we have our hype map generator, but more importantly, we actually sort of integrated it into our game. So when we hit play now, we have a hype map, and our buildings actually fall down onto the ground, so that they're actually on the ground, kind of. It's not perfect, but we'll get that better this episode probably. And we can move our turrets up and down like we had before. We can fire, and we have this little artillery game going on. It's actually kind of cool.
Look at that.
Wow, that one was a good one.
Yeah, that
A
was.
really good one. Maybe they'll come down and do more damage.
That'd be awesome.
Let's see if we get on this one.
There they were.
Bam. Yeah, the turn's in, but we don't care about the physics. Who cares about the physics? We'll just leave that running. So yeah, we've actually got what looks like a game here,
look at
which is
that.
kind of cool. And we've got a little ugly white mountainscape. Maybe we'll make a texture for it or something at some point here. Maybe we'll make a shader for it even. Maybe we'll just go all out on the terrain. But what I actually want to do is on this episode I want to do terrain deformation, mostly not because it will add much to this game in particular, but mostly because I get the question a lot. Surprisingly, I get deformable terrain quite a bit, and so I want to kind of go cover a little bit on how that works. I want to get the collision system a little bit fixed up, and we actually have one of our viewers, Saeed, sent me a message on how to fix our little problem. Remember how I said I thought the off by one was actually part of the problem? Turns out it is. And his fix was to actually just fix it from the other end, which I had not thought to do, where we just assume that the width and height are one less. And hopefully it'll actually fix it. I haven't actually tested it in the editor yet, but I'm going to try it right now. So remember, we had before this height map generator, and if we don't have it maximized on play, let me turn this off so that it doesn't get me every time. So when we have it running here, we can go into our generate height map thing, and we can change the size. No, not the size. We don't want the size. Oh god.
That's a big number.
We changed the noise scale. Oh yeah, okay. We added this real time button, so we hit the real time button, and then we changed the resolution and stuff. So we have this thing, and we had a separate collision mesh resolution, but the problem was the collision mesh wasn't matching even in cases where it should. So like we had a really good test case of 15 and 8 actually, which gives us, because we have an off by one, it's actually 7 and 14, which gives us this nice even ratio, so we should actually see these vertices lining up exactly. So the problem is our percentages are off, and the reason our percentages are off is because we assume that the values are going to go to one higher than they actually do because our script has a problem. And I was trying to fix this last time and ended up giving up on it, and then Saeed sent this in, and it's hopefully I'm pronouncing your name correctly. I'm sorry if I'm not, but he came in and just said, well, just change it here and here, and it totally works. So let's try it. So what his change was is we change it to width -1 here and height -1 here. Because the way that we're actually iterating over this, we never actually get to width and height. Remember when I was trying to make this equal so that it actually did go to the width and height? And we could change it all the other places, but we were unsuccessful on the show last time, so I'm not going to do it this time. We're just going to do it from the other direction. And we'll know that our script is off by 1. If you want to do extra credit and actually make this work the right way, where the sizes are what you'd expect, go ahead and do that. So we have this width -1, height -1. I think we have to put it somewhere else here too. Yeah, divided by width -1.
Okie dokie.
I don't even know if we actually have to change this one strictly. Though it would be nearly impossible for me to tell if the tangents were off, because I don't even think we're using shaders that use them right now. And even if we were, it's kind of hard to notice an off by 1 on that type of thing. So here we go. We're going to hit save. And let's see if this fixes our problem, makes it so this actually shows a little bit. Is finite... What the hell was that error?
I do not know.
Never saw that one before.
I hadn't either.
Alright, so we're going to change the noise scale to something. We're going to set it to real time so it actually updates.
I mean, anything should work, honestly.
So now if we go to the scene... Ooh, that's looking a lot better!
Yeah, that is looking
That looks right, actually. That looks downright right. So you can see the lines go across sometimes, but that's because there's no resolution there to have. But at the points where they meet, they actually meet now.
Yeah, they do.
Thank you, Saeed. Really appreciate it.
Yeah, that is awesome.
So,
there's a comment saying the edges on the cubes look strange.
Edges
question mark.
The cubes look strange. Which cubes?
That would be the cubes on the wall.
On the wall. Here,
Yeah.
let's see what the edges on the.
That
cubes
is
look
awesome,
like.
by the way. That is super awesome.
So yay! So now we can have lower resolution collision, and have it kind of match close enough that our brains probably wouldn't do better.
Pretty high. I mean, we're doing a decently
Yeah,
high resolution
we actually
right
we're
now.
running at a higher resolution. It was working just fine before, but now we actually can support arbitrary resolution and have it actually mean something. Where before it only worked if it was exactly the same.
The
Edges of the
on
cubes.
the cubes. So like shoot a wall, I think.
I'll just shoot my own wall.
No, don't do that.
Bam!
Oh,
no,
that's
the wall!
unfortunate.
What edges on which cubes? They look okay.
I'm assuming those ones. I think it's just probably because they are unshaded. They're only really being lit by one light source.
Yeah.
They don't have a texture on them.
He might be talking about the jaggy. I don't know.
Yeah,
maybe.
there is a little jaggy.
But there's no
on the side.
anti-aliasing that we're doing or anything, so
We aren't doing any post-processing.
edges of the cubes. But yeah, if you're more specific, we may be able to answer the question as to what's going on with the edges of the cubes. Right now, I don't know exactly what you're talking about. So in here we've got our dudes, and we're going to right now we do a raycast. So like if you look at the scene here, these things are actually floated up way off in space. And at the start, we generate the terrain underneath them, and then these drop down onto the terrain using a raycast down. So you can see that they actually can drop to different heights in certain situations. And the only potential problem here is we have the terrain kind of going through. It actually does end up working pretty well, but we're only doing a raycast right from the center. And so whatever the height is at that point is the height. And so depending on the way that the mountains are configured, we may or may not have it look very flat there. Like there might be places where it goes underneath or goes above. And what I suggested before is what we could do is we could actually just have a couple of posts going down so that it looks like there's supports. Mm-hmm. And that would solve most of the cases. And then there still will be the case where like right now you can see that some of the geometry kind of goes into the mountainside, which that almost looks okay because humans do that sometimes. Mm-hmm. But if we want to, we could actually flatten the terrain. Now, since we're going to be flattening the terrain anyway, I figure let's do the deformation first because it's the same principle, and then we'll apply that deformation to actually flatten out the terrain underneath the walls. What does that sound like to you? Does that sound good? Yeah. I basically want to make it so when we shoot the mountain, it actually goes down a little right now, or leaves a little impact point.
That sounds awesome.
And so let's start with that, and then we'll move up to the other stuff.
Also, another way of moving the bases down, you could theoretically do 2 raycasts, one on each side, and kind of take an average of the two, so you can put it more flush with the ground, not just the
This is true.
point,
This is true.
like
we could actually have
raycasts.
multiple raycasts. We could even do it kind of like what we were doing in the 2D game, where we have like ground checks or something. Like we just have hey raycast from here, 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 and then we just have a list of them. And we do it however the hell we want, and then we could have it so that it would find the average. The average is still not necessarily going to be good though.
No, not necessarily.
So I think that the deformation will probably end up being more potentially useful. Hopefully, we'll see how we actually do on this because this is going to be one of those guess and check math episodes. This is going to be a dangerous episode. So I kind of like that though. I didn't like last episode at the time we were doing it, but I actually kind of like what we did by the end of it. I know that sounds stupid. We've struggled a bit on it, but I actually am happy with where we're at right now in the project. So let's look at making some terrain deformation. So I'm going to create a script. Should we do it in the dangerous way? Yeah, let's just do it from the cannon's perspective. So we're gonna make a. Actually, let's just do it on the cannonball script.
Yeah.
To start with, that way we don't have to even mess around with starting anything fresh. So on the cannonball script, let me get rid of that real quick, folks. Hold on 1 second. Okay, it doesn't want to come up anymore. Okay, next time it comes up, I'll kill it. So what we have on here is this is our explosions code here, and it happens on collision enter. We don't check to see what we're colliding with at all. We just do an explosion on everything that's within the overlap sphere of the explosion radius. Which the only things in our game that are rigid bodies are the cubes and the balls themselves. But the cannonballs, you're not going to interact with 2 cannonballs. So this works. But what we're going to be doing here is going to be weird if we apply it to things that aren't like. We don't want to deform the blocks, I guess. Maybe we do. No, we don't. It's too hard too. There's a lot of.
No.
We can make a lot of assumptions with the height map, and so we're not going to do that. So we're going to have to check to make sure that these are not actually anything but the ground. So let's go ahead and do that real quick. So we're going to do on collision enter collision coal. So this represents. Actually, I'll call it collision. It's the collider that I have to call coal because if I just type in collider, I get something, and so you don't want to hide that by creating another variable named collider.
Yes.
So, but collision, there's nothing called collision, so we can just call it that. So, we get a collision, and so let's make it so.
Make it so.
So we'll add another section here. So this is our normal stuff. So we still want it to be in the not has exploded because we don't want it to just start blowing things up after the fact. So inside here, we're going to add in our deform terrain.
Could only have it affect the layer of collision that is the ground too. Or
yes,
terrain.
but we're going to need that
Okay.
information though. Is what I'm saying. It's like
Fantastic.
before we didn't even check it. And actually, just so you know, it is faster if you don't need to know what you're colliding with. The function call without the collision information will not calculate the collision information. So it actually does save you some on that.
Interesting.
But if you need that information for any reason, please put it in there. And we need it for the reason of being able to tell where the collision actually happened and to apply things to the ground. So if collision.tag, okay, collision.collider.tag equals, and I'm just going to make this up right now. I'm just going to call it terrain. So we're going to tag our terrain as.
Cool.
Right now, it doesn't actually have that tag, but we'll fix that. So if the tag is terrain, then we are going to deform it. And so what we're going to do is we're going to get the mesh of the terrain, which I think we can do that by getting the mesh filter component. So mesh filter. Yeah, let's get the mesh filter. Terrain mesh filter equals collision.collider.get component mesh filter. I'm gonna just check to see what we're doing in the height map generator, just to make sure I'm getting this from the right place.
All right.
So we get the mesh filter, we get the mesh renderer, we get the mesh collider. Why do we need the mesh renderer? What do we actually use that for? Did not mean to type X there.
Oh, excuse me.
Mesh filter. Foilter filter. No,
Foiltered again.
Renderer. So we add... Oh, we're adding the renderer. Okay, so I don't think we actually use it for anything really fancy. So we get the mesh filter on mesh. Okay, good. So this is exactly what we want. So we get the actual mesh here underneath. Mesh equals get component mesh filter.mesh. Well, we already have the mesh filter. I'm just going to throw this in here. Terrain mesh filter.mesh. And so now we can get at things in the mesh. So mesh dot triangles will give us our triangles, and mesh dot vertices will give us our vertices. Lots of fun stuff. So what we're going to be doing is we're going to be depressing the mesh points at these points. We're going to have to do it to both the mesh and the collider, but we'll do just the mesh first to make sure that we got something working. So our collision information contains some useful stuff. So collision dot point, no, dot hit, no. Maybe it's just in collider. Contacts, there we go. So collision.contacts contain all of the points which the object has hit. It's not vertices. It's what it is it's actually, say we have, I'm going to explain this wrong. You usually only get one per collision, but it's possible to actually get multiple ones, and they're all the points of intersection between the two objects.
Oh, okay.
I say you usually only get one because you really do. Even in cases where it looks like you'd have a lot of collision points, it actually just usually resolves just one. We're only going to care about the first one. Because that's usually safe enough, especially if we're just doing something where it hits something and it needs to, in general, in that area, do something.
Yeah.
So we're just going to pay attention to the first one. So this is a list of contacts, but we can get the first one by just using the standard array notation here. So we just do 0. So that's the first contact. The 0 is the 0th contact, which is the first one.
It's patient 0 of contact point.
And so dot point is our actual point. So this is our, I'm going to make a vector 3 collision point equals, and we're making a few more temporals than we usually do, and that's just because I'm kind of working through this one on the show, and I want to, if you word it out and you have things to work with, it becomes easier to kind of figure out what you're doing.
Yep.
So what we want to do is we want to take... Here, let's actually... Pixelmator, let's actually do a little diagram. A little horrible diagram.
Yay! It's horrible diagram time. I bet it won't be that horrible. Whoa, whoa,
all the
whoa,
stuff that
whoa,
was
whoa.
Before. Who cares? Who cares? Who cares? Hopefully I won't get a YouTube copyright violation for that sprite that was from Solar Jetman.
I get the feeling you probably won't.
I have a feeling I probably won't either, but it would crack me up. So we're just going to create a new, really quick one, just 500 by 500. We're not using this for anything. All right, so we have our terrain, which basically looks like, from the top-down view, our terrain looks very boring. Looks like, okay, I'm going to use the shift button. Okay, I'm going to use the shift button, but release it in between things. Okay, whatever. So we've got our terrain. And we're hitting some place on the mountainside in the terrain, so that's going to be our point X here. And then we want to take all the vertices that are near point X, so like in this case, it would be these 4 probably and nothing else, and depress them based on the distance from X. And we'll do that to a certain radius. And what I'm probably going to use for the radius is we'll use the explosion radius for now, although we may have to use a bigger radius to actually see what's going on. Mm-hmm. But we'll start with the explosion radius
was appropriate.
It certainly is appropriate, but we'll see this. And keep in mind, we're not going to be able to tunnel horizontally through things. We're just going to be lowering the height map. The reason that we're not doing the other stuff is actually really difficult to do without causing situations where if you need to make a hole in geometry, that is actually not easy. I know that sounds like it would be very super easy to put a hole in something. It is not easy to put a hole in something.
No, it's very difficult.
And so we're not going to be able to tunnel. We're just basically going to be able to, wherever it hits, we apply a vertical pressure downwards on the vertices is what we're doing. So we have our collision point and we have our mesh. So we have to determine vertices that are near that collision point. Now, the mesh dot vertices, this contains, and I'm actually going to double check this with Unity, but Unity mesh vertices. So the vertices are in object space, and they represent where in object space the vertices are. So it's all relative to the object itself. So if we query the actual position of one of these vertices, we will not necessarily get a point that represents the 3D world. It represents on just this object itself, just relative to itself. So we need to have the world space version of that. And it's actually very easy to convert between world space and not. You just add the transform position to the point, and you'll have it in world space all of a sudden, theoretically. So let's do that. So let's so we need to find. We're probably gonna have to compare to. In a perfect world, we want to minimize the amount of things that we have to go through. I don't know offhand an easy way to check to see if a vertex is within our range without actually just checking every vertex. Like, there's no automatic collider type thing that we can do in this case. There's not any helper functions that we can just rely on to get exactly the vertices that are affected by this sphere. Phil is going to try and make a liar out of me right now. He's doing the Google thing right now to check to see if I'm right. So what we're going to do is we're going to go through all of them. So for each, and we're going to describe them as vector 3s. Vector 3, actually can't, okay, so hold on. What do we have to work with here? Mesh dot vertices. Okay, they're already vector 3s. Perfect. So for each vector
I think
3
you're right.
in
I just wanted to check.
vector 3 vertex in mesh dot vertices. Remember, vertex is the singular form of vertices. It's not verti. So vector 3 vertex and mesh dot vertices. We're going to check to see its distance from the collision point. So if
You had a comment on your diagram. Said it was pro.
Wow, that's a pro diagram. Yeah, I know. We're spared no expense.
Yeah,
spared
seriously.
no expense.
Cooking with Unity spared no expense.
All right, so if the distance between this and the contact point is within our explosion radius, then we do something. So if vertex plus transform dot position. Remember, this is to get the not transform dot position. Sorry, collider collision dot collider dot dot position dot collision dot collider dot transform dot position. There we go. It's one of those.
Yeah.
So this is to make sure that we're basing it on it and not basing it on the projectile itself, which the transformed dot position is the projectile in this case. So if that is all right, so if this minus our collision point, which this is already in world space, so we don't have to worry about that. If this minus this, so this represents the vector between the collision point and it's the vector pointing to the collision point from the transform position. We don't actually care which way it's pointed, so we could actually subtract collision point from the other, and it would work exactly the same in this case. We're going to take the dot normalized is greater than, or is less than, rather, less than or equal to. We'll give it the benefit of the doubt, even though that means very little in this case. Not 2.5F, explosion radius. Shoot myself in the foot there. Hard coding it when we had a perfectly good variable to use. So what this means is if the distance between these 2 points, that's what the normal, when you wait, you don't want to normalize it, that's the wrong thing. Magnitude, thank you.
Yeah, magnitude.
Yeah, normalized is actually exactly not what we want. That would always come out as 1, so it would always work. And then I'd be sitting here yelling at it forever, and then someone online would be watching and crying, as they used to be like, "Why didn't he do it right the first time? Because now I watched him do all this stuff again." So, luckily, we avoided that this episode. So, so the other way you can actually write this, if you prefer this, actually, I think there is a vector 3 distance, vector 3 dot distance. Yeah, you can also do vector 3 distance between the 2 vectors. So it would just be you plop that into the left side, and then you plop this into the right side. Yeah. All it's doing is exactly this. And the reason I'm teaching it this way is just because if you run into any other programming language or something that doesn't have that helper function, this is how you do it. It's simple. It's a subtraction and a magnitude. And if you don't have magnitude in your vector 3 library, then you're in trouble already. Yeah. So that being said, it's really easy to get the magnitude too. You'll just look it up online. It's actually not difficult to figure that out.
When you break math down into small components,
so
it's usually
now
not too bad.
Keep in mind also both the distance and the magnitude function do a square root by nature. And we may actually fix that and optimize that out here in a second here. It's actually very easy to optimize out. But keep that in mind. There is another version called .square magnitude. This gives you the square magnitude, which is not exactly what we need here. But it also means that it saved you the square root. And consider we're doing this for every vertex on the thing. We're going to want to do it this way. But I'm just going to start it by making it work first. So if we are within the explosion radius, then we want to adjust the height of these by something. So I'm going to actually create a new variable because I don't think explosion force is a good thing to just hook into because we have it set at 100 and we don't even have 100 in the depth on this thing.
But
so I'm going to make a separate one.
See what it looks like.
Yeah, but I'm gonna terrain
it's
deformation amount equals, let's default it to 10.0f. We'll have that at the center of it. Oops. So what we're going to do is we're going to subtract from the y for this vertex and then reassign it somewhere. Hopefully we'll be able to do all of this. So what we want is vertex dot y minus equals we'll see if it even lets us do this. I don't think it's going to let us do this at all for a variety of reasons, but let's try it. So we're just going to minus equals terrain deformation amount. Let's just start with that. Let's just see what we get. See if this does something.
All right. Sounds good.
I don't think it's going to work at all for a variety of reasons, actually. And let's actually make sure that we can get this working. So so we have the mesh. We just changed the vertex. Actually, let's see what it is. Let's see what all this does. It may not do anything, as I said. Cannot assign members of vertex because it's for each iteration variable. Okay, so we can't actually do that. So we may have to actually change this to an actual for loop. Yes, we will. So for int I equals 0. I is less than mesh.vertices.length.
Okay. So it's going to go through every vertex.
Plus. Yeah, it's exactly the same as what we were doing here before, except for now we have an offset into the original array that we can actually adjust. So,
neato.
So in this case, it's going to be exactly the same as we set it up here, but instead of vertex, it will be mesh.vertices. I. And what this does is it gives us the vertexes in that location. Mm-hmm. And now we can adjust mesh vertices I dot y. And this will probably give us an error as well, as I said earlier. I didn't actually expect the previous problem, but
let's see what happens.
This one will probably not like it either. So we save that. Does it compile? It compiled. That's
wow.
good. That's exciting. Now, we check for terrain, so let's make sure our terrain is actually marked as such. So we want to make sure that this is tagged as terrain. And we need to actually make sure that it's tagged as terrain.
Yeah, we just don't need to
when
add
you add
it.
them, doesn't actually add it to the one that you added it through. So
exactly.
I just use that as a shortcut to going into like edit project settings wherever the heck tags are. Tags and layers, I guess, is the second one out there. But so we hit play, and the cannonballs already got this script on them because they're cannonballs, right? So let's see what happens if we try and hit some terrain with this.
Get that pesky wall out of the way first.
Just want me to move the wall or something?
No, just shoot at it.
Just shoot the wall? No, I don't want to shoot the wall.
Oh. I think you overshot it.
Oh! Definitely slowed things down. You saw that chunk.
No, I didn't.
It does some calculation. Here, I'm gonna try something fancy.
Oh, actually, I think the cannonball's still there.
Cannonball's still...
No, that was the cannon.
Yeah, that's the cannon. Let me move here. I'm actually going to try something here. I'm going to just drag a cannonball into the scene and drop it. See if this works. So prefabs, cannonball. We'll just throw this here. Well, it did actually hit and did something.
I saw a little chugging.
Are we getting any errors? No, we're not getting errors. Doesn't look like it's actually doing anything.
Could print a message saying, "Hey, stuff happened." Do a little print statement. Good old print debugging.
I'm just going to get rid of the player base here. Delete. And get rid of the player 2 base. Delete. Let's go back to the game and just see if we can like directly shoot at something. Really need to change the lighting on this so we can actually see what's going on.
Yeah,
make a texture or something. Did it do anything? I don't think it did.
I don't see it doing anything.
All right. I would have expected that to do something. Definitely slows down though. That's a good. That's exciting because that means that we're doing too much. So.
Well, because it's going through every vertex.
Yeah. Which, as I said, and we're doing a square root on every vertex.
We can't do a
then,
sphere cast or something like that, or like not sphere cast, but a overlap sphere to see what we're.
Well, a physics overlap sphere requires it to have a collider, so we'd need a collider on each vertex, which we don't have. So this is the way to do it. Believe it or not. Believe it or not. Let's actually see if we can speed up a little bit first, though. What I'm going to do is I'm going to make it so that we're going to use the square magnitude instead. SQR magnitude. And the way that we do this and make it so that we don't have to spend time on a time is money, right? Spend time on a
they said in Warcraft.
On a square root, or for that matter, a squaring operation, which is also
Someone said terrain mesh filter. Terrain mesh filter.
Yeah.
9 minutes ago.
Yeah, we have a terrain mesh filter here, and we have a mesh in it. Oh, I see. That's fine. Yeah, he's right. That's all he had to say. Because we're not actually reassigning this, so we want... Oh, wait, no, is that a reference? Is mesh a reference type, or is it a struct? Unity mesh. I think it's a reference type. Parent class object, yeah. So usually the way that they... Okay, it's important to call clear before assigning new vertices or triangles. Okay, I see what's going on. Okay, so we probably have to do a couple more things to actually get this thing reapplied to the mesh. But I want to fix the slowness first because it's already a problem. So even with the little that we're doing. So we have a square magnitude. So all we're going to do now is I'm going to create a new private variable called private float square SQR explosion radius. And we're going to set that in the start to be equal to explosion radius times explosion radius. So now we only do that once, and we have it cached. Now it does mean that changing the tweaking the explosion radius real time will not affect our explosion radius for the thing. So the tweaks will not work. So as a matter of fact, I'm going to actually put a little comment here. Does not update live for terrain deformation. It still updates live for the other stuff because we're just using it directly, but this one we're going to be using is less than equal to square explosion radius. And so let's see if that at least gets the chunking down a little bit less. I'm hoping it does, because I don't want this to be slow. So we didn't hit the train. Let's try it again.
That is not a train yet.
And still chugging. Wow, that's still a lot of chugging.
Huh.
Alright, so let's cache the transform position. So vector 3 collider transform collider position equals collision.collider.transform.position. So now we can do collider position in case this referencing was costing us
an incredible amount.
Yeah. And let's see. Save that and give it another shot.
Give it a go. Here we go down the hatch.
Still chunking. How many vertices? We probably have a huge amount of vertices.
Yeah, there are probably a lot of vertices, and it's
so
probably
we have a debug log in here already. Hold on, define debug.
It's probably also going through every vertex in the wall, or is it just going through terrain ones?
It should be just going through the terrain ones because it's getting the. It's getting this from the
terrain mesh filter. Yeah.
So collision. Okay, so let's also debug log. Let's actually do vertices dot length, and then let's also do collision mesh dot. Wait, where are we getting collision mesh? Oh, there it is. We're setting it to a new mesh, and then we're generating it.
Okay.
Okay, I can just do it from mesh. So mesh.vertices.length. Mesh.vertices.length. I'm just curious how ridiculous this actually is.
I am interested as well.
So we hit play, and
4,000? No.
That seems wrong.
It does seem wrong. Seems low.
Vertices. No, that's probably right. That's probably right.
4,000?
And the resolution is the same between the two because we didn't actually change that yet, right?
Yes.
Yeah. All right. So here, let's try. So 64 times 3. I don't know.
That's 64
So 64 times 64 times 3.
That is much more than it is.
Yeah, that seems like that should be the number that we're getting, and not
64 times 64 looks like the number we're getting.
Yeah. Weird.
Well, they do share vertices.
Okay, whatever.
Yeah, they share vertices.
Here, let's see how slow it goes if we set this at 32, just for fun.
Just for funsies?
For funsies. Much shorter.
It's much, much shorter.
Much shorter.
So it is cycling through all those vertices that it's having an issue.
Is there a way we can do it early out on this somehow?
I mean, it's hard to tell where that thing's going to land.
I mean, we're going to have to do a position check at some point, so...
Yeah, exactly.
We may explore this further to optimize it at some point. So let's try to just get it working for right now. Gonna put it back to 64 so we don't forget our shame. No, seriously, like sometimes you're just like, oh, it works now. Well, not gonna fix that.
So, but we need to know our shame.
Yes. So we have this mesh. I swear that's a reference, so that should just work, but it doesn't. So let's actually do it the way that they're doing it here. So get vertices, modify them. So we want a vertex list. So we want actually this might speed up too. Let's actually do vector 3 new vertices equals we'll do this after we get the mesh because it's part of the mesh, isn't it? So equals mesh dot vertices, and so then we're going to do new vertices dot length. Sometimes this actually matters, believe it or not, just depending on how this information is stored internally. Mm-hmm. I'm not holding my breath that this is actually going to speed things up, but at the very least...
theoretically, a reference is faster than calling something.
Yeah. Because I'm not sure if there's anything going on behind the scenes when you get a reference to... I don't want the length at all. I just want new vertices I guess. New vertices I. And then we set new vertices I.y. Save, and then once we actually have these changed, so let's see. First of all, I just want to see if it sped anything up. I don't think it did. Can't convert. Oh, vector 3 list. Sorry, not list, but vector 3 array. And one more. Dot length. There we go. It's capital length in this case.
That's silly.
Believe it or not, in C#, you're supposed to capitalize. Microsoft's style guide on it is you capitalize like full cap, not camel case, but like all first letters capitalized for property names. I actually disagree with them, but it is kind of their language. Unity disagrees with them too. So, did that actually, or did it just not hit anything? That was a lot better.
Faster.
It's a lot faster. Okay. Mm-hmm. So that made a huge difference already. And this is the kind of thing that when you're in danger zone, like anytime that you're doing something 4,096 times in a frame, probably gonna want to look there for your optimizations. So like anytime, it's really obvious in this case because when the ball actually hits something, but like anytime that you're going through a huge list of things, check those first. Don't check like the case where you grab a reference like once a frame.
Yeah,
no one cares. And people optimize for that, and I'm glad. I mean, you want to get in the habit of being optimal on things, but don't go overboard in the places that you're not going to see it. Oh wow, whew, that made me feel a lot better. Somehow this program had a little pixel there, and I thought I had dead pixel for a second. So I'm happy that that's not the case. So So now we need to actually reassign this stuff. So let's look at what we're doing. So we're modifying vertex attributes every frame. Continue. So we only need to modify vertex attributes. And we're not building a mesh from scratch. So this is the closest thing to our case. So we just reassign the mesh vertices, and that's it. So we'll just do mesh.vertices equals new vertices. So now let's see if it actually does something. The moment of truth. Again, maybe, for the first time.
Some look different a little bit, I thought.
I'm going to just try what I was doing before, where I just start dragging them onto the train somehow.
Drag it off to like a hilltop.
That's kind of fun.
Or you could do that.
It's working.
It's definitely working.
It's definitely deforming the train.
Neato.
That's funny that works. Because I guess I can't destroy it while I'm dragging it around or something. Or it's constantly creating it again after it's destroyed. I have no idea what it's actually doing here. But it does seem to work.
Yeah, it's certainly...
We can probably get the terrain really, really down there now.
Wow. That's pretty cool.
So yeah. Let's actually get some sort of texture map on that terrain. Let's just do something. Even if it's stupid. I'm just going to... The risk of... Yeah, that won't be a good texture map. I thought about it for a moment, and I'm like, nah, it's not going to be good. Actually, wait, I know what I'll do. Neo Texture Edit. I'll just grab something from here. One of the built-ins should suffice just fine for this. So what's one of the built-ins? Let's do this horrible, fiery cragscape thing. Actually, it's probably going to look terrible. I don't care. Maybe it'll... Nah, I don't think that'll be very readable.
Oh, that's awkward.
I don't know what's going on there.
Pushy Pixels commented saying, we started on time today.
How?
I do not know.
Huh. Oh, that's probably... I bet you that's Eric. I don't know. Maybe it's not. What the heck?
I don't know.
Eric, I did log in on his machine at some point, and I do know that they like to save that data forever for some reason, so...
Oh, that might be it.
Okay, let's make it brick texture. That'll be really dumb.
What's going on down there?
I don't know. Just ignore it.
Okay, I'm ignoring it.
It's going to be 256 by 256. Blah. I just want something that looks like something. Even if it looks wrong. So, do we have a textures? I'll just put it in materials for right now. And I'm going to go create a new material. I'm going to call this Stupid Brick.
Oh.
We're going to throw our texture in here, and we're going to make it just a standard diffuse. And then we're going to go into our generate height map, and we're going to give it this stupid brick material, and hopefully all the magic will just work, and it'll be a stupid brick. Yay, it's a stupid brick.
So give it more
now
offset.
let's make it so that we have on our stupid brick, we'll tile like 100 by 100. And yeah, that doesn't look so bad. I think you can get a better picture for the way the hills are, at least.
Much better.
It's amazing how much of a difference that makes. So now I'm going to do my same test again.
So that should probably be on the wall.
All around. I know, but who cares for right now?
I don't.
You like red?
Yes, I do.
So yeah, now you can clearly see that we are totally doing damage to the terrain.
Oh my god, it was Eric.
So Eric's logged into my account. Don't stop the stream or anything.
Yeah, that would be very, very bad. Very, very bad.
Luckily, I don't think that I could even direct you to how to do that, so hopefully that won't be a problem. So, what am I doing? So we have this working, but now it's working, as I said, we're doing it in a very basic way. It's just taking that circle and just any vertices that are in that sphere, just pushing them down by the deformation amount, which is 10.0f right now. So what we actually want to do is we want to actually make it kind of smooth between where it's hitting and the adjacent ones. So instead of doing just terrain deformation amount, we're actually going to do a lerp. We're going to do mathf.lerp, and it's going to be between 0.0f up to terrain deformation amount. And then what we're going to use as the amount is the actual distance between here. So I actually want to cache this so that we don't have to calculate it a second time. So I'm going to just quickly do that. Float square distance equals...
And this should save us some processing as well.
This one won't save us any processing.
Not any?
No, none on this one.
Oh.
It'll save us processing compared to what I could have written in the future that would have been bad, but so that is our square distance, and we will use it here so that we don't have to use it again, and then we're going to use it again in the loop. So square distance is less than square explosion radius, so we want it to be the percentage between the square distance divided by the square explosion radius. Wait, no, that would make the distance... Okay, yeah, this is actually what we want, but we need to reverse our terms here. So we want to actually do terrain deformation amount, and I'll explain what we're doing here in just a second. 0.0f. So, and the reason I'm explaining it is because I probably have it wrong, so we're talking through it. This is reductive debugging right here in the flesh. So, instead of changing it by the terrain deformation amount, we're changing it by the linear interpolation between the terrain deformation amount and 0 based on the square distance divided by the square explosion radius. And so what this means is if our square distance is at the furthest it can be, which will be just under or exactly equal to the square explosion radius, because we're in this thing to check to see if it was less than or equal. If it's at the highest amount, this will resolve to 1, and it will do 0 to the thing. And the reason we want that is because that means at the furthest radius, it does nothing. And at the epicenter,
it does the most.
It does the most. And so this will give us exactly our terrain deformation amount on the vertex that you hit. If you hit exactly on a vertex, it'll give you slightly less if you're a little bit further away, and it'll give you nothing if you're right on the edge. And as such, we're probably going to have to tweak this value a little bit more than just 10. But let's see what this actually looks like. And actually, I'm going to actually make the explosion radius and the terrain deformation radius separate at this point.
Sounds like a good plan.
Terrain deformation radius equals... And I'm going to default it to 5.0 F. Actually, let's do 10. 10 units. And so I'm going to change this to actually use the terrain deformation radius for square explosion radius. Okay, so I'm going to actually change this to be called square SQR deformation radius. I just didn't want to change it without changing the name of it. And then we want terrain deformation radius. Terrain deformation radius. And then we use this instead of our square explosion radius. Save. See if we got any compile errors. Probably unexpected symbol. Already got something. So I've got too many of those by a lot. And square explosion radius, we need to put that back in here. And there we go.
Oh, nice.
So now if we fire, I'm going to again just get rid of the bases real quick so that we can just do this stuff. This is why I love Unity. You can just do things in runtime and then not have to worry about them. And it deformed. Actually kind of looked good too.
Do it again.
Let's do it on... I'm going to try and hit...
Eric said to make it 1,000, by the way. He likes to see exploding polygons.
Well, you'll get them. They'll be exploding downward, though.
Yeah.
Yeah.
Neato.
That looks pretty good, actually. I'm liking that.
Shoot it again. That's cool.
So let's go ahead and do 1,000 just for the heck of it. Why not?
Do
Let's
a
just
negative
see it.
number.
A negative, so it goes up. Sure. Yeah. Why
and...
not? We can do whatever we want.
Yeah, we
do
can.
Do you want to do the negative or do you want to do the? Well, let's do both.
Do a random range.
Random range? No, I refuse.
Oh come on!
So
Random range.
cannonball.
1,000 to negative 1,000.
God, that'd be horrible.
Yeah, who knows what
Terrain
it would
deformation amount. Let's just do negative 1,000 so that we make a huge mountain wherever we hit.
Huge
Why
spike?
not? A huge spike, yeah. We'll just go... And then... Boom!
Holy crap.
Yeah! There's our huge spike.
It's not even the top of it.
No, it's not. Wait, we're further up. There it is. But you can see that it's like got this nice little taper to it.
Yeah.
And it wouldn't have had that nice little taper to it if
I know,
it wasn't
we
for
didn't do the
our
lerping.
change recently. So that's nice.
It's not a slurp. It's a lerp.
So it definitely works.
Yeah,
I would
it
say
does.
that's working kind of beautifully, actually.
I'd say
And
so,
I
too.
think 10 is actually good default values. So I'm going to save project, save scene. All right, and it's 8:58. We've been at this an hour. I'm going to quickly add our newfound knowledge to the placement of our thingy here, so that we have this flat area. So we're going to use our technology here. So in our where did we actually put this raycast drop?
Yep.
Let's do it. Although I'm going to change this to... I'm actually going to duplicate. Yeah.
Yeah.
Going to rename it to place fortress. Because we're going to be doing more than just that raycast drop now. And so now we go in here. We change it to actually be called place fortress. And now it doesn't bother me that we're going to additionally add... so we have a hit point here.
I have a comment saying, looks like Worms, but in 3D with towers.
Yep.
Which is a
Pretty much.
good, yeah.
Yeah,
description.
Worms is another game that inspires this type of turn-based artillery game.
Yeah.
Worms was so good. Scorched Earth is another great one. If you guys haven't played it, that was kind of a precursor to Worms. There actually is a 3D Worms-ish game that I played on, not Worms-ish, but 3D artillery with terrain deformation that used voxels on like the Mac in System 7, and I have no idea what it was called. And it was made by some indie, and I know it was an indie
Those are
because
the worst
there
when
was
you
a
don't know
button
what
that
they're
you could
called.
click, and it said "Will program for food," and he was holding it, and I think he wasn't being facetious at all. So
we have a suggestion to change the colors of the cannon and walls for each side.
oh yeah, we should totally do that. We'll do that on the next episode. That's easy enough. I shouldn't say it's trivial, but it is.
Easy enough.
So we're going to just go ahead and assume that we've collided with terrain because that's what this is for. So I'm just going to copy all this over and paste it here. And then we need to actually... So the collider position now is just hit that point. Terrain mesh filter is collision.collider.getComponent. So in this case it would be hit.collider.getComponent. That should be the same. And then we have these variables here. So we're not actually using the terrain deformation amount this time. So we will want to put a range here. So public float terrain flatten range equals... How wide is one of these? This is probably going to look really weird the first time, and we're just going to leave it weird at the end of the episode, but I just want to try and get it in there. So, Fortress Heart, what are we doing? Player 1 base. Player 1 base. How wide is this across? 30 across. So we'll do radius of 15.0 f. And so, what I'm just going to do is whatever the height is at the point that we got is the height that we're going to use. So we're going to need a square distance because we don't want to compare against that. So public or private float square terrain t's. And then start, we set square flatten range equal to terrain flatten range times terrain flatten range, so that we don't forget does not live update. Not that it would matter in this case because we're really only using it in start anyway, but
but let's not worry about that part.
So so the square distance is still new vertices I plus collider position. That's good. Minus collision point, which where's collision point determined? Collision point here is actually hit dot point. Sorry, we're changing it for a raycast. Theory's still the same here, though.
Yep.
So now instead of doing a lerp on this one, we wanted to actually just flatten it out. And as I said, we kind of want to flatten it to the height of whatever it was that we hit. Although that's... I'm just going to flatten it to 0 for right now. No, we have to do it at the height that's at.
Going to be the lowest height of the range?
So we need to convert into object space. So I think we can just subtract...
Don't want to just do the lowest of the range?
Well, we only have 1 point to actually get the information from anyway,
okay.
So we need to make another conversion at some point here. So square distance equals new vertices I. So let's find out the height. So the height will be float height equals so it'll be hit dot point. Can I just subtract the collider position? Wait, where's collider position? So collider position is not what I want. So collider position is not hit dot point. Collider position is hit dot collider. Actually, do I have a transform here? Hit dot transform. Yeah, I do. Transform dot
Collide
position.
Oh.
So that's the collider position. Hit dot point minus collider position. Hit dot point dot y minus collider position dot y. Let's see if this actually works. I have a feeling it's not going to do what I want it to do. So we just set the new vertices dot y equal to the height.
Okie dokie.
And save. And we check to see all the errors that we have. We have one. Square deformation radius isn't in anywhere. That's because we want it to actually be square. Flatten range.
We have a comment that says you are adding the hit dot point and taking it away. You should fix that. And then it says line 30 float square distance equals.
What did he say? Well, we actually don't have. This isn't right either. This is. Wait, yeah, it is. You're adding the hit dot point and taking it away. You should fix that. So we're adding the hit dot point. Where are we adding the hit dot point?
Oh, that's just what you said.
So we're not taking away the hit dot point. We're taking away the offset that's there. That we need this offset because these vertices are in local space. And what we're doing here is we're actually taking them from vertex space into local space and figuring out the height of that position, theoretically.
Theoretically.
I probably have it wrong, but we'll see. So let's see what this does. We hit play. And what should happen here, it looks like it did something.
Definitely did something.
Did it do what we actually wanted?
On the first try.
There's no way. Is there a way I can do... I swear there's a way to go into like some WASD movement mode on here. But I can never remember how to do it.
Probably involves middle clicking.
Oh, yeah. Right click. There. That's it.
Yeah, that looked like it did.
No, that A is left, but... And D is right.
It's
W and S don't do
all sorts
anything.
of funky. What about the other one?
I see part of our problem. So we're not raycasting down from what I thought we were raycasting from, I don't think. So what is actually doing this? So we're doing this on the player 2. So
oh yeah, it should be.
So player 1. Okay, so where's this point actually at? We want the not global. We want the pivot point. So no, it should be underneath there.
Yeah, that's what it looked like. What about the other one? Or was it only done on that one base?
Pivot actually what I want. So center. That's center of all points. So that's pivot is what we want. Let me just make sure. I'm going to make a sphere. I'm going to put it in the same position as player 1 here. Just copy component, paste component values, and then we make that looks like so it's definitely coming from there. It does look flat-ish at places.
We should look at the other one real quick.
So let's delete everything and just see what's actually underneath. Just go. So yeah, it does look like we.
Yeah, it looks like it's right on.
Looks like it worked perfectly.
Nice.
Awesome. Yay.
Yeah, that worked exactly like we expected. But.
So it does, but that radius doesn't seem right because that's falling off on the side here for some reason.
Probably the center of the thing, not at the very bottom of it.
So this is 30 across, but is it actually 30 across? Wait, so I just want this component. What is this thing? Is that it? No, I don't think that's it. Okay, it is it. So that's the center of it. Yeah, it's in the same position, so you would think that would be... Is our radius off? There's something else going on. Here, let's delete these things.
And we might just need a bigger radius. Because it's flattening that spot, but we just need a bigger radius.
But why does it fall off here? Like, that shouldn't be an edge that looks like that. It should look round. Like, it should be round around this exact point. No, not that exact point, but...
A point that's similar to that exact point.
Yeah. See, this one actually does look round. Well, there's going to be edges because of the way vertices work, but that doesn't look exactly right either. We'll play with it later. Anyway, I'm going to call it good on this episode, and I mentioned in a tweet that we might do a second one. We're going to discuss that. I also need to check to see what my workplace is doing because I might have to do a phone call with them.
There is potential.
There's potential that we may do a 2D episode after this one. I will set up the particulars. It'll probably be scheduled for around 9:30, 9:45. So thank you very much.
Hang on your seat.
So are we gonna do it? Are you ready for it? Are you ready for a 2D episode after this?
Yeah, sure.
All right, cool. I am too. So
you bought your whole seat, but you'll only need the edge.
That's a lie. You're gonna need the whole seat.
I only need the edge.
All right, you only need the edge. You can just edge sit all you want. So thank you very much for joining us tonight. If you need to email me for any questions, comments, concerns, if you want to fix any problems I have in my scripts, feel free. Pushypixels at pushypixels.com. You can also tweet me at Drakfire. That's DRAKFYRE. And you should buy Phil's game Robot Alone on iOS. It's awesome.
It's true. I made a game.
Yes, he did.
It is true. Anyway, you can email me. It's Philip at protosoftworks.com. That's where you can email me. You can also follow me on Twitter. Sometimes I tweet. Sometimes I don't. You can follow me. It's at Magmalemur. That's the @ sign, and then MAGMALEMUR. Magmalemur. And you should donate to Cooking with Unity. It's good times.
Yes, donate and you'll get swag, and hopefully some people will have gotten some tiles soon. Thank you for joining us, and you guys have a great night.
Yep. Have a good night.